Hello students, let us start with the next module, and in this module we are going to learn probability density function and cumulative distribution function. So let us start with the first part, that is probability density function. It is also denoted as PDF. When probability P can be expressed as a function of continuous random variable x which is defined over interval a to b, then the function f of x is called as probability density function. Let us try to understand this with the help of following diagram here. Here I have plotted the values for x and f of x as follows. The curve is for the values of f of x and the curve is from the interval a to b. So first of all, we must be very clear that in this, the probability will not be assigned to each point, but to interval of values. Here the interval is from point A here to the point B here. So moving further, the conditions which must be satisfied by f of x are as follows. First of all, if you see the graph, it lies above x-axis where probability is f of x, right? So probability is always non-negative. Therefore, we can say that the first condition is f of x should be greater than or equal to 0 over the interval a to b. For the next condition, let us try to understand this. The area under the curve, which is represented by the following shaded region, it is nothing but all the probabilities in that region. So it is equal to the sum of all the probabilities in that region, but it is the total probability. So I can say that the second condition is nothing but integral a to b f of x dx is equal to 1, where integral a to b f of x is nothing but the area under the curve, and this is equal to the total probability under the curve, which is equal to 1. So these are the two conditions which must be satisfied by f of x to be a PDF. Now moving further, let us try to understand some more things about PDF. Probability that x lies between two specified values of alpha and beta is defined as follows. First of all, here the value of the curve lies from a to b, and we are required to find out probability from alpha to beta between these 2 points. So it is nothing but it is area under the curve within these 2 points. It is shown as the shaded region in the graph here. So p of x greater than equal to alpha less than equal to beta is equal to integral alpha to beta f of x dx. Moving further, what we must note here is p of x equal to alpha is equal to 0. That is, probability for an isolated value of x is always 0. P of x greater than alpha less than equal to beta is equal to p of x less than equal to beta greater than equal to alpha is equal to p of x greater than alpha less than beta is equal to p of x greater than equal to alpha less than equal to beta, and this value is simply integral alpha to beta f of x dx. So this is important. We must understand that whatever the type of interval given to us, we have to integrate from alpha to beta only for f of x dx. Now moving further here, cumulative distribution function. Definition goes as follows. Let x be a continuous random variable with probability density function as f of x. The cumulative distribution function capital F of x is defined for every real number xi by the given relation. F of xi is equal to p of x less than equal to xi. That is, all the probabilities which are less than or equal to xi, and it is simply equal to integral from lower limit to xi f of x dx. So let us try to understand this more clearly from this. This is your x-axis and the limits are from minus infinity to infinity. This is your y-axis and origin. Now consider the following curve. This is curve for f of x. Now here, to find probability up to xi, the point is shown here on the x-axis. What we must do is we need to find area under the curve till xi. Means if I draw this line, I need to find out this particular shaded area. So it is nothing but it is obtained using the integration. So f of xi is equal to p of x less than equal to xi, which is equal to integral from lower limit to xi f of x dx. Here the lower limit for the curve is minus infinity. So here this is the value for f of x, which is cumulative distribution function. Now moving further here, what we must understand is if for any value of xi which is smaller than a, f of x will be equal to 0, and for any value of xi greater than or equal to b, f of xi will always be equal to 1. Here observe this graph. This particular region is p of x less than equal to xi, and this particular blank region is p of x greater than xi. Now we know that if I add these two, the total probability will always be 1. So I can say that p of x greater than xi is equal to 1 minus p of x less than equal to xi, which is nothing but 1 minus f of xi. So this is regarding cumulative distribution function and probability density function. Thank you.